Okay. Now, I'm going to introduce you to a very important little piece of information right here, and that's this little tail piece. This right here is what is called an initial value. Okay? Hence the name initial value problem. And the idea of an initial value is it's information about the function that you're actually trying to find. Okay? Without actually knowing what that function is yet. Okay? But you do know this information. Now, obviously, they'd have to give that to you. You can't just make it up. If they don't give it to you, then you can't do anything. It's just a straight up question. Okay? So we want to determine the function f of x for the following. Well, we are not given f of x. We are given f prime of x. Now, I want us to go back to like November. And let's imagine I gave you this question. Don't write it down. And I said find f prime. Okay? Well, how would we find f prime? What would we do?
Differentiate.
We differentiate. What's the derivative of f of x?
F prime of x.
Ah, that's exciting. What's the derivative of x squared minus 7?
2x.
So we differentiate. Okay? So the derivative of f of x is f prime. Would we agree?
Yes.
Okay. So let's come back over here. This is f prime. And we want f. So to go from f to f prime, we differentiate. To go from f prime to f, we have to
Anti-differentiate.
got it. So let's anti-differentiate. So the antiderivative of f prime is f of x. Yeah. Incredible. Now, if we anti-differentiate the left, we better anti-differentiate the right. What's the antiderivative of 2x? Well, it's going to be 2 times the antiderivative of x. Well, what's the antiderivative of x?
1/2 x squared.
1/2 x squared. Okay. The antiderivative of negative 3,
Negative 3x.
and then of course plus the arbitrary constant c. Still need that. Now we can clearly see that those 2's are going to simplify nicely, and we're left with f of x equaling x squared minus 3x plus c. Cool. All right. So, is everybody okay with that little process there?
Yep.
I'll ask that again. Everybody okay with that?
Yep.
Cool. We know from the initial value that f at 0 is 1. Would we agree with this?
Yep. Yes.
All right, let's plug it in. F at 0 is equal to 0 squared minus 3 times 0 plus c. I think that's okay. Well, what's f at 0?
1.
Oh, good. 0 squared?
0.
Negative 3 times 0?
0.
Oh. So our constant is 1. Our c is 1. And therefore, f of x will equal, well, x squared minus 3x plus c, but c is just 1. And there it is. So that is the function whose derivative will be 2x minus 3 such that f at 0 will be 1. So we actually solved the problem. We found the specific c. The specific c for this case is 1. Now obviously if this initial value is something different, we can clearly see that this constant will possibly be something different other than 1. Okay, it could be lots of different things. However, it depends on that initial value, what that will be. Go. No, it can't be. In the sense that the value that you would be plugging into the function would be a point that's actually on the curve. And so you would never have a point on the curve where the c would have to be infinity. It would be a discrete value of some kind. It could be gross. It could be like pi squared over 7 or something. These are facts, but it could be, yeah, all those types of things. Make sense? Cool. Great. Any questions with that? Okay. Number 2. F double prime. Say what? Okay. Yeah. Equals 6x minus 10. And we're going to say that f prime at 1 equals 2, and then f at 1 is 1. Okay. Well, let's attack. Well, the question says determine the function f of x. But we're not given f of x. What are we given? F double prime. Now, very similar to what I wrote over before, if we had f of x equals x squared minus 7, to get f prime we would differentiate, but then to get f double prime we would have to differentiate again. And remember how I told you is that there was no shortcut to go from f to f double prime. You would have to go f prime, f double prime. Well, now we are starting with f double prime, and we are getting f of x. Well, in order to do that, to go from f double prime to f of x, we are going to have to antidifferentiate twice. So let's begin. Our first antiderivative, f prime. Okay. Well, the antiderivative of f double prime is f prime. We good with that?
Yes.
I'll ask that again. We good with that?
Yes.
Good. Antiderivative of 6x. Well, this is going to be 6 times the antiderivative of x, which is a half x squared. Subtract the antiderivative of 10, which is negative 10x, plus c. How did we do? Yeah.
For like the second derivative, could it also be a capital F1 prime, or does that not make sense?
So you're saying like if it was capital F like that? Oh yes, that notation could be used. We don't usually see that notation. The reason being is because we know that capital F prime is in fact F, but I understand what you're saying, like if they gave it to you this way, could you say that? Yes, 100% you could. But they don't usually try and confuse you with the notation. They'll just be more straight up. Yes, but definitely it could use that notation. Simplifying this just slightly, 6 divided by 2, of course, is 3x squared minus 10x plus c. Okay, and BD, no big deal. Now, let's take a peek here. If you look at your initial values, what do you notice? What's that? Yeah. F prime at 1 equals 2. Now, the only way that we can use this information is if we have the function f prime. Well, do we have that?
Yep.
So guess what we should probably do?
Use it.
Use it! Yeah! Right now. Use it. Plug it in, okay? So, f prime at 1 is equal to 3 times 1 squared minus 10 times 1 plus c. Of course, f prime at 1 is 2. That's going to be 3 minus 10 plus c. 3 minus 10?
Negative 7.
Move it over.
9.
9, yeah. So our c value is 9. Isn't that fun? Now, unfortunately, though, we have not answered the question. Because what the heck was it? What's the question? Find f! There's f. But that's not f. That's f prime. So guess what we have to do? Anti-differentiate again. Okay. But don't just jump to the answer just yet. So, the antiderivative of f prime is f. Would we agree? 3x squared. Well, this is going to be 3 times the antiderivative of x squared. Antiderivative of x squared.
1/3 x cubed.
Thank you. Minus 10 times the antiderivative of x. Antiderivative of x.
Half x squared.
Good. Plus the antiderivative of 9.
9x.
Okay. Now, this is where we have to be careful. Can you put c there? No, you cannot. Why can you not? Because you know c. Yeah, it's not arbitrary anymore. We know what c is. What's c?
9.
9. So if you put c there, then that means you're telling your